So as part of this topic, you're going to need to conduct an investigation to measure the coefficient of static friction between an object you choose and a surface. In order to do this, you're going to need to be able to do something which is a bit tricky. You're going to need to be able to break the vectors into components which are parallel to the slope that you're using and perpendicular to the slope that you're using. So let's have a look at an example now where we will be using this method. So you'll need to use the same method when you do the calculations in your investigation. So the question is, a 570 gram block is placed on a surface. The surface is initially horizontal, but the angle theta is increased until the block just starts to move. At this point, the angle is measured to be 27 degrees. Calculate mu s, which is the coefficient of static friction, between the block and the slope. Here's the diagram showing the situation. Okay, so to solve this problem, we're going to need to realize that it starts to move when the force down the slope is equal to the maximum static friction force. So what we can do is we can break the forces felt by this block into components. So we've got the weight force acting downwards. Now we can break this into a component parallel to the slope and also a component perpendicular to the slope. And so let's look at the geometry involved in this situation. Imagine this triangle here to start with. This angle in here is 90 minus theta, just because we've got this is a right angle triangle and that's theta, so this needs to be 90 minus theta. So this angle and this angle have the same value, so that angle in there is 90 minus theta, and so that tells us this angle here is theta. So what we're going to need to know is we're going to need to know first the force down the slope, so that's this component here. So let's call that F down. Now using trigonometry, SOHCAHTOA, we can see that F down is opposite the angle theta and the hypotenuse is mg. So we've got sine theta is equal to F down over mg, and so our force down the slope is equal to mg sine theta. Now what we need to do is work out what's the maximum static friction force. So we know that the static frictional force goes up to a value of mu s times the normal force. Now before, the normal force has always just been mg, but in this case the normal force opposes just the weight force into the slope, which is this side here. Let's call this F perp, for F perpendicular to the slope. So we can work out the force perpendicular to the slope, and the normal force will have the same magnitude as this force. So to do that, this is adjacent to this angle theta, so we can use cos theta is equal to adjacent, which is the perpendicular one, over the hypotenuse, which is mg. So F perpendicular is equal to mg cos theta. And so we've got that our frictional force is equal to mu s times the normal force, which has the same magnitude as mg cos theta. So this will start to move when the force down the slope is equal to the maximum friction force. So we've got mg sine theta is equal to mu s mg cos theta. So these mg's actually cancel out, and we're left with mu s is equal to sine theta over cos theta. And now there's a relationship in trigonometry that says that sine theta over cos theta is just equal to tan theta. So this makes this a bit easier to solve. We're told in this question that the block just starts to move when theta is 27. So we know that tan of 27 is equal to mu s. And so mu s in this case is equal to 0.51. And so that's how we solve that problem. So remember, when you come to your investigation, the force down the slope is given by mg sine theta, and the frictional force is given by mu s mg cos theta.